Cramer's rule. Cramer's rule is used in matrices, also known as determinant method. It is an important method applied to solve a system of equations, wherein the values of the variables in the system are to be calculated using the determinant of the system. So who is the founder of Cramer's rule? So, Gabriel Cramer. This rule is named after Gabriel Cramer, who published the rule for an arbitrary number of unknowns in 1750, giving a general formula for the solution for any unknown in a linear equation system having a unique solution in terms of determinants implied by the system. So let's move on to our example. Our first example is 2x plus y is minus z is equals to 1, 3x plus 2y plus 2z is equals to 13, 4x minus 2y plus 3z is equals to 9. So we have 2x plus y minus z equals 1, 3x plus 2y plus 2z is equals to 13, and 4x minus 2y plus 3z is equals to 9. So let's find first the determinant p. And finding the determinant p, we have a1x, a2x, a3x, b1x, b1, b1y, b2y, b3y, c1z, c2z, and c3z. So A is for the coefficients of x, B is for y coefficients, and C is for z coefficients. So let's first substitute the numbers. We have 2, 3, 4, 1, 2, negative 2, negative 1, 2, and 3. And finding out determinant p, we have a1 multiplied to, if we have here, a1, then we must eliminate row 1 and column 1. We will put b2, b3, c2, and c3. And then, if we have b1, we must eliminate column 2 and row 1. Minus b1 is equals multiplied to a2, a3, c2, and c3. And then for c1, we have a2, a3, b2, and b3. And now we must substitute each coefficients to its particular value. So 2 times 2, negative 2, 2 and 3, have b1, 1 times a2, 2, 3, 4, 2 and 3. And for c1 we have negative 1 times negative 1 times 3, 2, 3, 4, 2, negative 2. Then we will cross multiply this and this. 2 times 2 times 3 minus minus 2 times negative 2 minus 1 times 3 times 3 minus 2 times 4. And then we have minus 1 times 3 times negative 3 minus 2 times 4. Then, after that, let's evaluate the numbers. So we have 2 times 10 so we have 2 times 10 minus 1 times 1 minus negative 14. And then 20 minus 1 plus 14 is equals to 33. So our D is equals to 33. And then if we want to find the x and y z values, we can also use this method. So for x, we have the formula of dx over d. For y, we have dy over d. And for z, we have dz over d. So let's start with the first one, dx. In dx, we will substitute the coefficient x with d1, d2, and d3 since we are finding for dx. So d1, d2, d3, b1, b2, b3, c1, c2, and c3. Let's substitute the values. d1 is equals to 1, 13, 9, 1, 2, negative 2, negative 1, 2, and 3. Then dx is equals to, so 1 times 2, 2, negative 2, 3, minus 1 times 13, 9, 2, 3, plus negative 1 times 13, 9, 2, and negative 2. And then let's evaluate the numbers. Is equals to 6 minus negative 4 minus 1 times 39 minus 18 minus 1 times negative 26 minus 18. Then after that, then we will get 10, 21 plus 44 is equals to 23. And our dx is equals to 23. So let's move on to dy. So for this case, dy, d1, d2, and d3 will substitute the y coefficients. So a1, a2, and a3. Then d1, d2, d3, c1, c2, c3. For A, we have 2, 1, and -1. Then 3, 13, 9. No. 2, 4, 9, 3. Is equals to 2, 13, 2, 9, 3. -1, 3, 4, 3, plus -1 plus 2, 3, 4, 13, 9 plus 2 times 39 minus 18 minus 9 minus 8 minus 1 97 minus 52 is equals to 42 minus 1 plus 25 is equals to 66. So our dy is equals to 66. And then for dz, just like a while ago, dz, d1, d2, and d3 will substitute the will change the coefficients of z since we are looking for dz. A1, A2, A3, B1, B2, B3, D1, D2, and D3. 2, 3, 4, 1, 2, -2, and 1, 13, 9. So 2 times 2, -2, 13, 9, minus 1 times 3, 4, 13, 9, plus 1 times 3, 4, 2, -2. So it equals to 2 times 18 minus -26 minus 1 times 27 minus 52 plus 1 times -6 minus 8, and then we'll get 88 plus 25 minus 14 equals to 99. So dz is equals to 99. So we got d is equals to 33, dx equals 33, dy is equals to 66, and dz is equals to 99. We can substitute these values in this equation in order to get the x, y, and z values. So x is equals to dx over d. X is equals to 33 over 33. X is equals to 1. Y is equals to dy over d is equals to 66 over 33. Y is equals to 2. And z is equals to dz over d, 99 over 33. Z is equals to 2. So these are the values of d, x, and y, and z, and that is just how you will solve matrices or determinants using Cramer's rule. That's all, and thank